Good day everyone. This is Ivan Escama speaking on behalf of my colleagues Alan Roberto and Professor Edwin Abucay. I'm here to talk to you about our big idea, building extraction and regularization through utilization of distributed computing for disaster risk reduction management and community resiliency. Alright, let's get started. Here's the problem. The Philippines is situated inside the Pacific Ring of Fire, which makes it vulnerable to natural disasters such as typhoons, tsunamis, volcanic eruptions, and earthquakes. Mapping of buildings is important in disaster risk management and hazard assessments. Disaster risk management plans often lack updated data on the location of infrastructure and residential areas. Local offices often store this information in tabular formats on paper without the spatial information. This leads to the lack of an integrative solution in harnessing various spatial data towards disaster risk reduction and management. Through the use of Geographic Information Systems, or GIS, we can map these buildings in a digital format and perform different analysis and processes to aid in disaster risk management. Mapping of buildings is usually done through digitization. Digitization is the painstaking process of drawing lines and polygons to represent various stuff like roads, administrative boundaries, and for our case, buildings. This process is quite tedious and time-consuming, and thus, the automation of such a task is important. Through the use of remote sensing technologies, specifically light detection and ranging, or LiDAR, building footprint extraction can be done with minimal user intervention. Remote sensing data such as LiDAR and satellite imageries are considered big data. Thus, it can be computationally expensive to run algorithms for building footprint extraction. And now, here is our proposed approach. We have developed a prototype of an algorithm for the automated extraction of building footprints in LiDAR datasets. The algorithm outputs an S3 shapefile of generated building footprints that can be visualized by most GIS. This algorithm is also capable of smartly utilizing a computer through the maximization of available resources whilst not interfering with its current usage. The primary inputs for the algorithm are LiDAR point clouds in the LAS file format, an open source format for storing LiDAR information. The LAS datasets can be requested from the DREAM PhilLiDAR 1 program, the Philippines' flagship program in using LiDAR for disaster risk management. These LAS files are pre-processed using LASTools, a proprietary LiDAR processing software suite. The pre-processed data is then fed to the algorithm described earlier to produce the output shapefile. We are processing huge volumes of data, thus, the algorithm we developed can take a long time to run. Since we have an existing computer laboratory for our project, UPLB PhilLiDAR 1, we can fully utilize the laboratory through the use of distributed computing. Distributed computing is a computing model that makes networked computers, or nodes, share a common goal or finish a big task. Our laboratory has 10 HP Z230 tower workstations connected by a wired network. Our approach follows the master-slave paradigm where one computer sends units of work to other computers for processing. We have developed a prototype of the system Bertud, which stands for Building Extraction and Regularization through Utilization of Distributed Computing, as our platform for distributed computing. Bertud has a master program which provides an interface for sending work to other computers through the network. It also has a slave program run by other computers which in turn waits for the master program to send work, and as it receives work, it runs the algorithm mentioned earlier. Building extraction through Bertud is efficient since workstations are not usually maximized by our project personnel. The algorithm that we developed can smartly maximize the usage of workstations without interfering with the personnel's work, since building footprint extraction is not the only task of our project. Building footprint extraction is not enough. We also need to associate other information like building use, the number of floors, building age, etc. in order to make sound observations and decisions for urban planning, hazard assessments, and disaster risk management.
Created using Bertud.